4.5. 4.5 is called polynomial inequalities. This is what 4.5 is. So we're going to take a look at questions about polynomial inequalities. So the first question from the homework is, negative 5x minus 17 is less than 3. So we're going to solve negative 5x minus 17 is less than 3. So this is not a polynomial inequality. It's a very basic linear inequality. So we will add 17 on both sides. So negative 5x is less than 3 plus 17 is 20. Divide each side by negative 5. Cancels out. Whenever we divide an inequality by a negative number, we must flip the sign and then divide these two numbers, and then you will get x is greater than negative 4. So when you see this question on the homework, you're going to choose A, and you're going to type here x must be greater than 4. So I think, yeah, x must be greater than negative 4. This is how we are going to do the first question on the homework. So starting second question, actually what we need to focus more, this was like a more of a review question. So if I have x squared minus 5x, x squared minus 5x minus 6 is less than a 0. How can we solve this polynomial inequality? Step number 1 will be, we're going to factor what we are given. So when we look at the factors for x squared minus 5x minus 6, factors are x minus 6 and x plus 1. Because when I multiply these two numbers, their product is negative 6. And when I add them up, their sum is negative 5. And when we multiply these two factors, we want them to be a negative number. Then we set x minus 6 to be a 0. And then this gives me x equals 6. Then we want to set x plus 1 to be a 0. And this gives me x equals negative 1. So now, on this number line, we have two critical points, negative 1 and positive 6. And we don't want to be equal any of these, because when we get equal to them, we will become a 0, but we want to be just less than a 0. We don't want to be equal to a 0. So these two will be open circles. Now, we're going to test a number between negative infinity and negative 1. So any number is good to test. I'm going to go ahead and choose maybe like negative 2. When I test negative 2, I want to plug it in here. Negative 2 minus 6, and then negative 2 plus 1. When I calculate the sign, this is a negative 8, and this is a negative 1. And when I multiply two negative numbers, I will get a positive value. This means anytime I use a number between negative infinity and negative 1, I am going to get a positive answer, which is not for this problem. This problem wants to only get the negative region. So this region will be rejected, because whenever we use the x value from this region, we are receiving a positive answer. Now we're going to test the middle region. Any number from negative 1 to 6. You can pick any number as long as the number is between negative 1 and 6. So we're going to pick 0. So now we're going to plug in 0 for x and see what happens. I will have 0 minus 6, and then I will have 0 plus 1, and I will check the sign for this selection. That's a negative number, and that's a positive number. Then we multiply a negative number by a positive number, we get a negative answer, which is what we need for this question, because this question is asking for less than a 0. Final region is anything after 6. So I want to just test something more than 6, like 7. But again, you can use any number you like. So I need 7 minus 6, and I need 7 plus 1. This is a positive number, and this is a positive number. And when we multiply two positive numbers, we will get a positive answer. So the only accepted answer will be here. We want to only use the numbers from negative 1 to positive 6. And these two both are excluded, because when you use these two endpoints, you actually become a 0. But the question is not less than or equal to a 0. It's just less than a 0. So this will be the answer for question 2 on the homework. Now we will look at question 3 from this homework. And then for question 3, we have a similar polynomial function. So what we are given is this time. We are given x squared minus 6x is greater than a 0. Again, first we're going to find the factors of this question. So x is a common factor, parentheses, x minus 6 is greater than a 0. When I set this to a 0, I get x equals 0. When I set this to a 0, I get x equals 6. So I'm going to have two numbers, 0 and 6. And this time the question wants to have the positive regions. So we're going to test something less than a 0. So let's test -1. So when I test -1, again, we will always test here. So I need x times x minus 6. So I need -1 times -1 minus 6. This is a negative number, this is a negative number. So their product will be a positive number, which is what we need for this problem. Now I'm going to test the number from 0 to 6. So any number from 0 to 6, I would like to test number 2. And then we're going to test it over here again. So I need a 2 times 2 minus 6. So this is a negative number, but this is a positive number. When we multiply a positive number by a negative number, the answer is a negative number. So that means for this question, we cannot use any number from 0 to 6 because we want a positive number. And finally, we're going to test something more than 6. So let's test something like 7. So when I test 7, I need 7 times 7 minus 6. So this is a positive number, and this is a positive number. When we multiply two positive numbers, we will get a positive number again. So this will be a positive region. So in this question, I can use any numbers from -infinity to 0, and 0 is not okay to use because 0 makes me equal to 0. Union, there's one more region I can choose numbers from. So the other region starts from 6 and it goes all the way to positive infinity. So I want to just write the answer one more time. On my method, you will give them your answer as answer is -infinity to 0, union 6 to infinity for question 3 for this question when you need to. So you're going to pick A, and you're going to say that the solution set is the union of those two intersection points. And for number 4, what we are given is x squared minus x is greater than 2. So we have x squared minus x is greater than 2. And then the question is solve this inequality and choose the correct solution set. Now, this is a quadratic inequality, which the first step we need to do is we will keep the x squared minus x here, but we will move the 2 to the first side as -2, and then we're going to make this greater than or equal to 0. So this is how we set this 2 as 0 first. Then we're going to factor our quadratic expression. So the factors I need is x minus 2 and x plus 1. Because when you multiply these two numbers, their product is -2, and when you add them up, their sum is -1. So the critical point, one of the critical point is 2, and then the other critical point is -1. So on a number line, we have to show them that -1 is one critical point and +2 is the other critical point. Now, we are going to test one point from each of these regions here to check if we are getting a positive answer or not. So let's check something like -2. Let's check because -2 is in this region. So we're going to decide whether this region is included or not. So I need -2 minus 2 and -2 plus 1. So this is a negative number. This is also a negative number. And negative times negative is always a positive number. So this means this region will be included in our solution. So if we actually start setting up our answer, the solution set, because when I pick the number from this region and this end is always -infinity, this end is always +infinity. This is from -infinity to -1, and -1 is not included because it makes us a 0, and we don't want to be a 0, we want to be more than 0. Union. Now, let's test something from between -1 to 2. So smartest number to pick is 0. So we will need 0 minus 2, which is a negative number. And then we will need 0 plus 1, which is a positive number. And this is going to give me a negative answer, which I don't want it. So I'm not going to include this particular region in my solution set. Finally, I want to test something more than 2. So let's try 3. What happens when we decide to use 3 for x? 3 minus 2 is positive. 3 plus 1 is positive. And then when we multiply two positive numbers, I get a positive result. So this is even good for me because I want to get a positive result. So the final region I can use in my solution set is 2 to infinity. This is how we're going to insert number 4 on the hand. So for number 5, we have a similar inequality. So let's just go down. Number 5. For number 5, we have x squared minus 2x plus 6. The question is x squared minus 2x plus 6, and we want this to be less than or equal to 0. Okay. I don't need to move things around since this is already less than or equal to 0. The only thing I have to do here is go ahead and factor this. So one factor will be x. Here actually, this question is not possible to factor. The roots are here, complex solutions. So because factors of 6 is either -1 minus 6, but the sum would be a 7, or it's going to be x minus 2 and x minus 3, but sum would be a 5. So we're just going to solve this question by changing this number to a 5. And then if we just change this number to be a 5, that means the factors are x minus 2 times x minus 3, and we want this to be less than or equal to 0. So when we make the number line now, this is going to give me a 2, and this is going to give me a 3. So 2, 3. So again, one region is from negative infinity to 2, middle region is from 2 to 3, and last region is from 3 to infinity. We're just going to test numbers. I will test something here. Let's just test 0, because 0 is located in the very first region. So 0 minus 2 is a negative number. 0 minus 3 is a negative number. When I multiply these two negative numbers, I get a positive answer, but this wants to be a negative. So we're just not going to include this. If we choose something between 2 and 3, so I'm going to choose 2.5. 2.5 minus 2 is a positive number. 2.5 minus 3 is a negative number. And then when I multiply a positive number by a negative number, I get a negative answer. And then finally, if I test something more than 3, something like 4, 4 minus 2 is positive, 4 minus 3 is positive, and then we multiply two positive numbers, we get a positive one. So this one is supposed to be positive, so we're only negative in the middle. And because now this question is less than or equal to, that means endpoints will be included in the solution set. Instead of parentheses, I will be using brackets because I can be a 0 or I can be less than 0. 2 and 3, they make me exact equal to a 0, so that's okay to use them. But if we want to also stay negative, we're going to use any number between 2 and 3. This concludes 4.5.